Good to see you again, Laura. Thanks for coming back.
No problem.
Can you tell us, for the total lab conclusion, what did you learn and prove it? Specific examples.
Well, as a whole, this entire lab has ultimately taught us how to take two-dimensional problems and translate them into the 4D world. It's one thing to see a formula and have to work it out on paper, but to use that formula, make an estimation, and then actually see it proven is a much better learning experience. Another learning point of this lab was seeing outside vectors such as wind, rain, and temperature in action and adjusting calculations to correct for them. Using the range formula, we can calculate many other things, such as how far a pitcher can throw a baseball and how far a cannonball can be shot from a cannon. One thing that was learned from this lab was also team building, which can be used in many work and social situations outside of school.
Those are some great examples, Laura, of inside the class and for everyday life. Can you explain some of the formulas that you used throughout the entire lab?
Sure. The most important formula we used in this lab was the range formula, where v is the initial velocity and theta as the angle at which the rocket is shot at. The formula is used to find how far we estimate the rocket to travel. This formula can also be manipulated to find velocity in the x, velocity in the y, and time in the air. We also use the circumference formula, 2 pi r, to calculate the diameter of the Pepsi bottle. Another equation we used was force equals mass times acceleration, to find the weight of the rocket in newtons.
How do you think, though, that you could have perfected the lab, maybe for next time?
Well, perfect results are hard to come by, especially when we factor in uncontrollable outside vectors such as wind. But to get perfect results, the first thing to do would be to build our rockets exactly like each other, like clones. This would help with consistency. We would also need to ensure that the rockets were filled with the same amount of water, every time. Lastly, another big factor would be the actual shooting of the rockets. We would need to make sure that the rocket was stood at exactly 90 degrees or 45 degrees, and that the person who pulled the string was consistent each time.
Can you give us some group dynamics? I mean, we are an awesome group and all, but what did each one of us do?
Sure. Well, it was hard to get everyone together all at once, so the work had to get split up. Michaela and Melissa were designated camera women throughout the process. During the build, Sarah and Christian recorded the procedure and Melissa recorded the materials. Myself and Michaela filled the rockets with water to find the 80% mark and the 90% mark. Michaela and Christian worked on attaching and making the wings, and Melissa and me cut tape at exact lengths to ensure that the rockets would all be the same weight. For the actual shoot, Sarah, Michaela, and Christian helped to fill the bottles. Myself and Christian pulled the string, and myself, Michaela, and Christian took measurements from the launcher to where the rocket was landed. All the while, Melissa was capturing the process with videos and pictures. For the write-up, we all split up the work evenly. Each of us did a conclusion, and Michaela worked on some of the charts for the lab, as well as doing all the purposes and put together the whole PowerPoint. Melissa also did data, while Sarah did procedure and Christian did materials. Together, we all worked to edit and add the procedure, materials, and observations. In all, our group worked really well together during the 20-plus hours we worked in this lab. Most parts of this lab were fun and enjoyable, such as the shooting and the building, but the actual lab part was a challenge.
Can you give us some other examples of likes and dislikes for this lab so Coach knows what to do better?
Well, typing up the lab and all the data and calculations was tedious and difficult. The building of the rockets was fun, and it was nice to have some freedom for creativity. I liked this lab better than many others I've done in the past because it wasn't just based in the classroom, but there was way too much going on to call this just one lab.
Can you compare and contrast this lab with others, or do you think we should keep it?
I think this lab should be kept for next year because at some points, aka the launching, the lab was fun. It was cool to see physics in action, and it would be better for next year if there was a separate syllabus specifically for this lab so that there's more structure and that we know exactly what is expected. Overall, this lab was definitely a learning experience and should be used in years to come.
And that's it!
Yee!
Thanks for watching. I'm Melissa.
And I'm Laura.